चलो गेट का क्वेश्चन नंबर 48 देखते हैं। इस क्वेश्चन के अंदर बोला गया है कि विच ऑफ द स्टेटमेंट्स आर करेक्ट अबाउट रेलू एक्टिवेशन फंक्शन। एंड रेलू एक्टिवेशन फंक्शन जो है इसकी डेफिनेशन भी दी हुई है। ये बोला गया कि जो रेलू एक्टिवेशन फंक्शन है दैट इज रिटन एज मैक्स ऑफ जीरो एक्स कॉमा जीरो। ठीक है, एक बार इस रेलू एक्टिवेशन फंक्शन को प्लॉट भी कर लेते हैं एक्स वाई एक्सेस पर। सो अगर हमारा एक्स जो है if that is less than 0, that is this area, the value of activation function would be 0 because x is negative and the maximum between negative number and 0 is 0. So that's how. So for the values of x which is less than 0, the activation value would be 0. So that's the red line. And when we take the for the values of the x which are greater than 0, the maximum would be x. So the ReLU function would be x. So that is a straight line with the slope as 45 degree. So this is how the ReLU activation function looks like. Okay. So now we can see that this particular activation function which we have drawn has an is in continuous function everywhere, right? So that's the one of the correct answers. We have to specify which of the statements are correct about the ReLU functions. So this we can see from the graph that this activation function is continuous everywhere. There we don't see any gaps here. Also, the second option says that whether the ReLU is a differentiable everywhere. But we know that we have a sharp point here at 0. So this particular ReLU activation function is not differentiable at 1. We can see a tip at, because if we go from here and so the value wouldn't be, so this function is not differential at this particular point because we have two slopes at this particular point. One is being shown by the light blue color and the another slope. So at this particular point we have two slopes. So that's why this function is not differentiable at x is equal to 0. So the option C is correct, which says that ReLU is not differentiable at x is equal to 0. Okay, that's now we have countered the statement B. Now we look at the option D, which says that ReLU of x is equal to ReLU of ax. Okay, so let's look at this now. So it says that ReLU of x is equals to ReLU of ax. We have to either prove that this is the case for all the real numbers or it's not the case. So now let's look for the case when x is equals to is less than or equal to 0. So when that's the case, ReLU of x can be given by max of x comma 0, and since x is less than 0, so the value will come out to be 0. Similarly, ReLU for ax is max of ax comma 0, and since x is less than 0, so ax would also be less than 0, right? Because x is less than or equal to 0. Similarly, ax would also be less than or equal to 0. So this value will again come out to be 0. So for x less than 0, so when x is less than or equal to 0, we say that ReLU of x is equal to ReLU of ax. But if is the same condition applies for x greater than 0 also, we'll check that. So for x greater than 0, ReLU of x comma 0 will come out since x is greater than 0. So the maximum of x comma 0 would be x, and so the ReLU of x comma 0 is x for x greater than 0. Similarly, we'll also find the ReLU of ax comma 0, which is max of ax comma 0. Since x is greater than, when x is greater than 0, and in the from the start of the discussion I've been assuming that a is greater than 0. Okay, so that's the case when I'm assuming that a is greater than 0. So if a is greater than 0, x is greater than 0, so the max of ax comma 0 would be ax. But that's not the case. That's so for this particular situation, ReLU of x comma 0 is not equal to ReLU of ax comma 0. So we have got one case, at least one case, where this condition does not hold for n, for some value of a. So this particular situation is not correct, so this particular option is not correct, right? So you can also, for the entire discussion, I have assumed that a is greater than 0, and I hope you have understood that now only option A and option C are correct options for this question.